Now that we're familiar with gravity, it's time to introduce an idea called gravitational field. Rather than thinking of gravity as being just a force acting between two objects, we often find it useful to consider the existence of some change in space itself caused by the existence of matter or the existence of a mass at some location. That's what we mean when we say a field. Field is just a disturbance or a change in the condition in space. And if we put some new object in that space, it can be affected by the existence of that field. One way that this is commonly modeled is by thinking of as our object with mass as being like a bowling ball, and of space as being like a trampoline. That's what this image is showing. And if we place the bowling ball on that trampoline, the bowling ball causes a change in the trampoline. It makes that trampoline bend toward the bowling ball. And so if we put another object, like this little golf ball, on the trampoline, we can see that it would roll toward that bowling ball. Now we have to be careful not to take this analogy too literally, because space is not two-dimensional, it's three-dimensional, and if it were two-dimensional, we'd have to ask, well, what's pulling the bowling ball downward to cause this change in space? So it's just an analogy, and it does have some limitations there. But this idea of changing the space itself, not just affecting the objects around it, but changing the emptiness of space, or the fabric of space-time, that's what we're talking about with a field. We find that the magnitude, or the amount, the strength of the gravitational field is proportional to the gravitational constant times the mass of the object divided by the distance from the object to some point in space, and that gets squared. And then we label this gravitational field with a lowercase g. Now this ought to look quite familiar to you, because if we just add m1 times m2, then we have just the equation for the force of gravity. So essentially what the magnitude of the gravitational field is it's a ratio between the force of gravity acting on some object because of this change in the space and the mass of that object. Now if we calculated for the Earth what the gravitational field would be at the surface, we'd find, and actually we did this in the previous video, we'd find a value of 9.8 meters per second squared for the gravitational field. So it turns out that the strength of the gravitational field is exactly equal to the free fall acceleration due to gravity around a planet. If we're looking for the free fall acceleration around some new planet, we could just use this version of the equation. But again, all we need to know here is that g, the gravitational field, is equal to the ratio of the force of gravity acting on some mass to the mass of that object.